Okay, there are some exceptions to the law of sines, and this is sometimes called the ambiguous case, where there could be a couple things going on. And this is when you're given a side, and finally an angle. All right, so look at, we're given side A, we're given side B, and then we're given side A. And I'm going to show you the possibilities. So when you are given that situation, a side A, by the way, notice what it spells backwards, right? So you have to be very careful given this. So here are the stipulations. When the A side is bigger than the B side, you have one triangle, you're safe. However, when the B side is bigger than the A side and the A is bigger than the height, meaning these two, A could come down here or A could come down here because it's bigger than the height, you're going to have a possibility of two triangles. All right, and then in one of the videos, this video, I'll show you how to solve that. Then there's going to be this third possibility when B is bigger than A, but A is smaller than the height. There's no possible triangle. Look at that. If A is shorter than the height, it's never going to reach B. That is not a complete triangle. So let's go ahead and see what that looks like. So state the number of possible triangles that could be formed using the given measurements. So let's see what this is. All right, so I drew the diagram already. It says in triangle EFD, measuring angle D right here is 18.1 degrees. This is D, and this is F. So notice we have a side, and we have an angle. And remember, this is the rule. If the opposite side, in this case it's side D, but we said if A is bigger than B, then you do have one triangle. So this one, we're good to go. We're good to solve. So now let me do this so we're not looking at too much stuff. So we're given the information. Go ahead and, oops. Take that away for a second. So we have triangle KHP. So we know that this is side P. This is going to be angle P. This is going to be angle H. And look at what happens. We could put B, the adjacent side, the B side, well, it's P in this case, but in the theorem, B is greater than A. But notice this height right here, that opposite side is going to end up being longer than the height. And I can't manipulate that very easily without possibly changing it. But if you were to try to straighten this out, look, it would swing down here someplace. But that exact same height, if I can get it moved, could swing the other direction, and we have a possibility of two triangles. We have this possible triangle, or, let's take that away, we have this possible triangle. And you have to solve for both, but here's the trick. Solve this one first, and then whatever angle this is, remember these are both the same size, so we know that these two angles are the same size. So when you solve, when you put it into a calculator, let me put it this way. When you put it into a calculator, it's going to solve this triangle. And you're going to find the measure of this angle. Once you know the measure of this angle, which happens to also be that angle, just do 180, subtract this, because remember, these two angles that sit on the line add up to 180. So 180 subtract this will give you this angle, And now you can solve this triangle. Okay. And then let's go ahead and see what happens here. Is that let's see if that's the third. All right, so here we have this information. We have F is 158 degrees, E is 35 yards, and F is 13 yards. So this is angle F. So the side opposite F is 13 yards. Let's say this is angle E. Side E, this is 35 yards. So there's no way that if this is 35 yards, there's no way that 13 yards is going to reach F. So this is the example of the no triangle. And again, we are given a side, and an angle. All right, that's it.